Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here. It's our third video on the equation of a circle. Let's start by recalling the formula for the equation of a circle. Now, suppose we have a general circle with centre, general point AB, radius, general amount r, and any point on the circle xy. Can you remember the formula for the equation of that circle? Pause the video and double check you can recall that. Well, you should have got that the formula was x subtract a all squared add y subtract b all squared is equal to r squared. And it's really important you learn that formula. Now, remember where we got that formula from. We got it from the fact that a circle is a set of points a fixed distance, called the radius, from the centre point. And we applied Pythagoras' theorem to get this circle. And what it tells us is any general point xy anywhere along that circle will always satisfy this equation. Let me give you an example of one. Here's an example of a circle. X add 1 all squared add y subtract 3 all squared is equal to 5 squared. Just before I explore this circle, can you pause the video and double check that you know the center of this circle and you know its radius, and having found those you can sketch the circle. So that was in equation of a circle 1. Pause the video, double check you can do that. Well, we know that the general formula for the equation of a circle we've just stated is x subtract a all squared add y subtract b all squared is equal to r squared. So if a circle's in that form, we know its centre is AB, its radius is r. So we can write that in this form by writing x. We have to write add 1 as subtract negative 1, so it's in this form here. Add y subtract 3 all squared is equal to what squares to 25? 5 squared. And therefore from that information we can state that the centre must be negative 1, positive 3, and we can state therefore that the radius must be 5. And we can use that information to sketch the circle. We can say it's negative 1, 3 somewhere here, and we can say it's got a radius of 5, so it looks something like that. Not accurate, just a rough sketch. Alright, now let me just remind you a little fact therefore. Any point at all, say that was a general point in the circle xy, or another point over here, I might call it xy. Anything that lies on that circle, when I put that x value and that y value into this here, I will always get the answer 25, always. Right? Now, what if I gave you the following problem? I gave you 3 coordinates, 3, negative 1, 0, negative 1, and 3, 0. And I said to you, do they lie on the circle? Are they outside the circle? Or are they inside the circle? Now, you could just sketch it and see if you could work that out, but that's not going to be accurate. It'll be hard to see for sure whether that's inside or outside the circle. So, what you want to do is you want an algebraic way of doing this. Now, the one thing we do know is any coordinate, as I've just said, that lies on this circle, if you put the x value and the y value in here, you will get 25. If though you put the x and the y in here and you get a number bigger than 25, well, that's telling you that the distance between the coordinate you've got and the center of the circle is more than 5 squared, is more than the radius of 5, so it must lie outside the circle. If on the other hand you substitute in a coordinate here, an x and a y, and you get a number smaller than 25, that's telling you the distance from the center to your coordinate is less than the radius of 5, so it must be inside the circle. So that's the technique we're going to use to do this rather than having to sketch. So let's get straight on and do an example. And I'm going to start off with the very question I just posed on the other slide. So for this circle here, and these points here, I want you to state whether A, they lie on the circle, B, lie outside the circle, or C, lie inside the circle. So what we're going to do for the first one, we're going to call that Rx and call that Ry. We're going to substitute those values into this expression here, the left hand side of the equation of a circle. If we get 25, hey presto, it lies on the circle. If we get more than 25, the distance between our point and the center of the circle must be more than 5, more than the radius. Remember, this is 5 squared. So therefore it lies outside the circle, and if we get a number smaller than 25, it must lie inside the circle. So let's have a go at that. So what we're going to say is we're going to substitute in 3, add 1, all squared, add -1, take away 3, all squared. We're trying to work that out. That's 4 squared, which is 16. That's -4 squared. -4 times -4 is positive 16. So that's 16 again, and we get the answer 32. Okay? So, what can we state from that? Well, we can state, therefore, that, using the 3 dots here, 3, -1 must be outside the circle. Because the 32 is bigger than 25, which is indicating that the distance between this point and the center of the circle is more than the radius in this case. So the radius, which would have been 5, and 5 squares to 25. So that's how you know. Let's have a go at the next one. We substitute in x is 0 and y is -1 into the left-hand expression and compare it to 25. So we do 0, add 1 squared, add -1, take away 3 squared. That's 1 squared, which is 1. -1 take away 3 is -4. -4 squared is going to be -4 times -4 is positive 16. So we get the answer 17, right? And again, that is telling us that 0, therefore 0, -1 must lie inside the circle. Because 17 is less than 25, which is telling us that this point has a distance of smaller than 5 away from the center, so it's inside the circle. And the last one, we're going to substitute in 3, 0, so we're going to say 3, add 1, all squared, add 0, take away 3, all squared. Well, 3 add 1 is 4, 4 squared 16. 0 take away 3 is -3, -3 squared is positive 9, and 16 add 9 is equal to 25. And 25 is the same as the 25 in the equation of our circle, so 3, 0 must lie on our circle. So therefore, 3, 0 must lie on our circle. On the circle. Alright? And we're done. Let's have one more example to double check you know this method. So pause the video and answer the following question. So what we're going to do is we're going to substitute in for each of these x and y into the left hand side here and compare it to the answer you get when you do 13 squared. Now 13 squared gives me 169. So we're going to compare the number to 169. So let's do 3, take away 3, all squared, add -1, add 3 squared. 3 take away 3 is 0, 0 squared 0. -1 add 3 is 2, so that's add 2 squared, which is 4, and we're going to get the answer 4. And therefore 4 is way less than 169. Okay, so therefore 3, -1 is inside the circle. Let's do the same for the next one. So we're going to say 0 take away 3 all squared, add 12, add 3 all squared. 0 take away 3 all squared, well 0 take away 3 is -3, -3 squared is 9, so we're going to have 9. 12 add 3 is equal to 15. 15 squared, we should know that is 225, and 9 add 225 is going to equal to 234. 234 is bigger than 169, therefore we must know 0, 12 must lie outside the circle. Therefore 0, 12 is outside the circle. And the last one, let's substitute in these. We're going to say -9 subtract 3 all squared, add 2 add 3 all squared. -9 take away 3 is -12. -12 squared is positive 144. Add 2 add 3 is 5. 5 squared is 25. If I do 144 add 25, I get myself 169, which is the same as 13 squared, and therefore I can say that it lies on the circle. So -9 2 lies on the circle. And that's it for this skill. Thank you very much for watching.